Hello, so welcome back, and we're going to be taking a look at yet another disgusting motherboard. So we have another board here that has no liquid on it, and as you can see, there is some green shit over there, which is sign number one that we are dealing with somebody who doesn't tell the truth. And sign number two that we're dealing with somebody that doesn't tell the truth is that when you open it up, we see a bunch of rice inside of it. So all the stickers inside the machine got rice everywhere. Because I'm sure the computer decided after it didn't get liquid spilled on it that it just wanted to eat some nice wholesome rice, and that's why there's rice all over the inside of it. Now let's just scroll through over here and take a look at the other side of the board. And oh, gross! What are you growing something? What the fuck? Alright, anyway. So, we have two different sections over here. The first is the ISL 6259. These are current sensing resistors. So the whole idea here is... well, we'll go over what a current sensing circuit does once we remove all of this disgusting garbage. Let's just remove Thunderbolt first, because Thunderbolt's just got to go. So, let's heat this up, add a bunch of flux. Oh, even the fume extractor isn't getting rid of the smell of this. Yeah. What is this? Feces? I get all these stuff in the comments like, this sounds like the Bob Ross of electronics. Man, Bob Ross never had to deal with this shit. Never had to heat up stuff that smells like cow feces and look at it in real time and combine it with liquid. Bob Ross just, he got the good life. He got to paint happy little clouds and happy little trees. He never had to heat up happy little cow dung shit smelling. Bleh. Get the fuck off my board. This Chip, come on, Chip, give up. I know you got a big heatsink pad under you, but it's time to give up. Everything else around you gave up. Come on, get up, mother. Damn. I have the JBC nozzle off. It's at 450 C, which is highest temperature, and 100% air, which is the highest air. Damn. Alright. Might as well move the current sensing section of the ISL 6259 because that's nasty. Get up. Now it's going to be time to do a little bit of renovations. Let's do some renovations. So I'm going to put my larger iron tip back on. We're going to do some work with that. I was thinking of including a drone on the show just for fun. But I went on eBay and it's like, there are drones that go for $800 new, and there are people selling them with, and it looks like, like the way this looked on this little spot, the entire motherboard will look like that, and they're selling it for $350 or $400. And I was looking at the YouTube analytics or the Google analytics, and I mean, there are some of these where I made $200 or $300. Awesome. And then there are some where I made, $5. But on average, I get about $20 for each one of these shows that I do. The motherboard ones. So I can't really buy a $300 drone that's not fixable to include in a show that will make on average $20-25. But I am open to it. I did want to see inside one of those and just out of curiosity see what goes wrong with them. I can't do it as part of my regular business. That's just not possible. Because everybody who comes in the store it has to be fixed within a day. If it's not fixed in a day, it's all chargebacks, angry Yelp reviews, and screaming at how disgusting and garbage we are. So I can't do that. I was just looking at doing it as a hobby. I'm still gonna look into that, see if I can find myself a cheap cheap broken drone to include in the show, because a bunch of people have asked about that. And of course, we're going to go through the same thing that we go through, with most standard consumer electronics. There's not going to be schematic, board view support, anything like that. There's only one place here that's authorized for the Phantom, DJI stuff, all that. There's only one company that's certified for it in Manhattan, and their ratings kind of suck. And I'm not sure if it's because the company itself sucks or because drone customers that want their stuff fixed suck. I haven't figured that out yet. I'm not really looking to dive into that until I have an answer to that. Because sometimes you find it's just the industry itself that sucks and that people's expectations are too high. But you never know. But I did want to get my hands on a couple of drones that died from like liquid or crashing or something, just out of curiosity, just to open for the hell of it and see what's going on in there. I think it would be fun. It would definitely be a fun show. Something fun to put on here. But obviously it has to make sense. I can't pay $300 for something to include it in an episode that'll make 20. And you also have to consider the fact that a lot of people who watch this for the stuff that I do may not watch that because they don't want to watch drone repair. I didn't subscribe for drone repair, so there's a chance of it making $10. But I'm definitely on the lookout for it. A new employee here said that I flew my drone into a tree, and I'm like, where? And she said, oh, it's already gone. And I go, damn. 'Cause I would have climbed up the tree and gotten it. It was a $40 drone though. I'm surprised that something that costs $40 can even fly, much less have a camera in it. The thing had a damn camera in it. It had a camera. It was a remote-controlled helicopter thing. $40. I don't understand how that's even possible, but. Like that you can even sell something that the retailer makes profit, the company who made it makes profit, that the employees get paid, the manufacturers get paid. That just seems very, very, very cheap. That seems super cheap. The described issue with this is it didn't turn on. I saw it was turning on but turning off right after, so I'm guessing that could be a combination of current sensing issue because that current sensing resistor was destroyed, and I'll show you what the current sensing is at the end. Or it could be that Thunderbolt was shorting PP Bus G3 hot to ground. Equal chance for both, seeing as how bad this thing it looked. But there's an equal equal chance that it was just a combination of both. All right, ugly board, isn't it? Yeah, I agree. Ugly, ugly board. So I'm going to grab a donor for this model. And we'll go from there. It is awfully tempting to not put Thunderbolt back on. Sometimes you can't put Thunderbolt back on. The board itself is too messed up, and if you try putting Thunderbolt back on, you wind up killing the board's chance of ever turning on again, and internal shorts, and all sorts of nastiness. But there's a chance that this is savable, so I'm not going to go that far yet. Let's save Thunderbolt. Thunderbolt matters. Make Thunderbolt great again. Okay, so it started with current sensing. I know it's going to flow into place when I heat the stuff next to it, so I'm not overly concerned with it getting soldered perfectly as soon as I put the resistor down. Here I just feel like a cog or a robot. Lots of soldering of lots of little things. See, surface tension will blow everything into place nicely. That could definitely use a little bit of a touch-up. This tip is too big. I'll go back and touch this up with the micro pencil later, maybe. I mean, I can do it, it's just a pain in the ass. See? Okay. A robot should be doing this. The little Apple recycling robot probably does this. I should be replaced by a robot. See, now what a lot of people get wrong is what a lot of people like to do. What they do is they keep changing the board they have under the microscope, and they put the board that they are soldering from or to under the microscope. What I do, just so that you can see over here, is I have the board that I'm taking stuff off outside of the microscope, and then the board that I'm soldering onto under the microscope. The reason I do this is so that I never lose the component. I can just go ding, down, ding, down. If I had to continuously move the board, when it comes time to replace 16 or 25 components, that doesn't scale. Further, I don't need accuracy to rip something off, because I want you to think about this. Why do you use a microscope? You use a microscope so you can see things perfectly and so that you have an exact idea of what it is you're doing. Do you need an exact idea of how you're ripping a component off or how you're placing it on? I personally don't care how I rip the thing off. I care how I put it on, but I don't care how I rip it off. See how they all float into place? That was beautiful. So we just continue down the road here. People who ask me, why don't I take these all out of little spools or order new ones? And do you know how long this would take? Do you know how long this would take? Let's say I click the resistor. I get its number. I look its value up in the PDF. Then after I look its value up in the PDF, then I pull it out of a drawer. Then I take that little resistor out. Then I put it on. Oh my God, it hurts to think about. The sheer inefficiency of it all. All of that work, and you may have not even solved the problem. There may actually be another problem when I'm done with this. So can you imagine if I took this and made it take 3 times as long and I didn't solve the problem? Woo! I can't show you my ticket list because it has all the customer names and whatnot, but there's 2 pages. A page is 100 tickets. So I don't know how many there are, but I know that there's more than 100. I'm not dealing with over 100 tickets and like looking up little individual values and then, mouser.comming, buying each individual one, waiting for them to show up for people who want this to be done tomorrow. No way, it's just not practical. You find donor boards that don't have signs of use. These boards that have the holes in them, meaning somebody at the factory didn't like the board for whatever reason. That look good, and you go forth and you do what you can. But when you get the board snobs, and the thing is, you can always tell from the comments which people have never actually tried to run a production facility doing something like this. From the comments. Look at him, you taking parts off a donor board, blah. I bet he doesn't even offer a warranty. Yeah. Yeah, right. And I bet you've never run a business. Yeah, okay. Still got a little bit more to go here. My hot air station beeps off after 600 seconds, which means I've been doing this for at least 10 minutes. Alright, we take another piece. Oh, it popped. The last one popped off. Really? That really necessary? The last piece, man. The last one. How fucking dare you? It's always right at the end that something like that has to happen. Melt, mofo. That'll melt into place. I don't care how diagonal it is right now. It's going to move into place once I go to put my T29 boost regulator. This is a big chip. So I'm glad I don't have the nozzle on the JBC JTA, because if I did, this would take forever. So we're just gonna wait and heat this whole thing, heat this whole area of the board. Eventually the chip will come off. Come on. Damn. These boards sure know how to absorb heat. I'm at the highest setting, 450 Celsius, 100% on the JBC JTA. This is a powerful station. And this board has been having this section heated the entire time because I've been taking all the components off one by one. Alright, this is going to take a while. Now once it's aligned, I'm going to get ready to push it down. Because even though it's aligned, it's not actually pushed down on the board. So it's aligned, and now it's pushed. It's nice and flat. Now I'm going to get rid of the excess solder. Beep. Good HAKKO. Whoa. The iron almost burned me. The cable caught itself on my outer section of my hand. It did this. I was soldering and it did this, and then it was like this, and I was trying to grab it. But the more here's the thing: when you go to try to grab it, if it slides down and this hits you, burn. That's painful. All right, so well, let's see if this damn thing turns on and stays on. That's step number 1. Yay! The fan spins. And it stays spinning. Now let's see if it gets me a light on the screen. How much luck do I have? Does it boot and do all those great things that you expect a computer to do? Rice. I can't believe that. Ahem. There we go. And as you can see, we have made progress. Now let's go over what that little section that was all burned and screwed up is for. Toss these burning donor boards down there. This out of the way, so I can make use of my nice spacious desk and my luxurious, beautiful office. All right, so. R7152 is part of a current sensing circuit. So if you want to know how much current the machine is using, what are you going to do? Let's go over current sensing really quickly. So if you want to know, let's take a couple of different attributes of a stream of water. So you have, let's see, you have how much water is in the stream. Let's call that voltage. It's probably a really bad explanation because it's late and I want to go home. So you have how much water is in the stream right now? Like how wide? No, bad explanation. How wide is the stream? Voltage. How fast is the water flowing through the stream? Current. You can see how wide the stream is from up on the mountain, but you can't tell how fast the water is flowing through without actually being in the stream. You have to put your hand in the stream, or you have to be swimming in there to know how fast it's moving. So you need to have something in the stream if you want to figure out how much current is being, or how fast the water is flowing, how much current is being used. So over here, let's take a look at this circuit. So the way that this works is you have this resistor which is in the stream. So you have from adapter, this is the power that comes from the charger. Before the charger goes to this transistor, which is going to make the main power for the machine, it goes through this resistor. So this resistor will have an idea of how much power is going through the circuit, and it reports it back to this chip. Now the whole idea is there's going to be a voltage difference between the top of the resistor and the bottom of the resistor, and that voltage difference is reported to the U7100 chip, which then magically figures out how much current the system is using based on the voltage difference. But long story short, if I want to figure out how fast the water is moving in the stream and I'm sitting up on the mountain, I need to ask a friend who's by the stream, hey, can you put your hand in the stream? And then the guy who puts his hand in the stream can yell to me, hey, this is how much current we're using. This is how fast the stream is going. So think of this as me on the mountain. This is the guy in the mountain. And think of the resistor as the guy with his hand in the stream. Now, R7151 or R7152, let's see, R7152 was burned. So there's two current sensing circuits. You have the current sensing circuit from the adapter, so it can tell how much power the charger is using, and you also have the current sensing from the battery, so you can tell how much current the battery is using. This is very useful for, let's see, what's a good example? All right, so let's say, you're just doing nothing with your computer, and it says 8 hours of battery remaining, right? It knows how much current you're using. That's how it can tell you have 8 hours remaining. Now, let's say you start playing a video game. The second you start playing a game, it says 1 hour remaining. The way that it knows when you have the exact same battery percentage, whether you have 8 hours remaining or 1 hour remaining, is going to be based on how much current it thinks you're using. So this is why the computer needs to know how much current it's using so it can report things like this to you. So R7152, if this resistor is blown and this resistor is fine, it's going to think, holy crap, there's an infinite difference between one side of the resistor and the other. Because keep in mind, the way that it reports this difference is it looks at the voltage on each side of the resistor. So over here, there may be 12.56. Over here, there may be 12.54. It reports that as a difference of 0.02 volts. And the voltage difference is going to be higher based on how much current the system's using. So if it's using more current, bigger voltage difference. Less current, lower voltage difference. So if it sees that I have 0 volts on one side and 12 volts on the other or something like that, it's going to think, oh my God, we're using millions of amps. And it's going to turn itself off because it doesn't want to die. It's get smart like that. So that's what we did to fix this machine. And I also even put the Thunderbolt circuit back on because I want it to be nice. And I don't always do that if the board is totally destroyed. So that's it. And as always, I hope you learned something.